In this lecture, we're going to walk through an actual test-driven development coding session. For the example, we'll be using the FizzBuzz code Kata. The name Kata comes from martial arts and means training exercises. So code Kata are training exercises for programmers. The FizzBuzz Kata is pretty simple. We'll be implementing a function that is passed in an integer value as an input, and the function will return the string fizz if the passed-in number is a multiple of 3, buzz if the passed-in number is a multiple of 5, and FizzBuzz if the passed-in number is a multiple of 3 and 5. If the value is not a multiple of 3 or 5, then the value itself is returned as the string. I'll be using Eclipse as my IDE for this example and all the example coding sessions for this course. But the TDD process should apply regardless of the IDE you're using. In some of the future lectures, I'll show you how to build and use Google tests and some of the other common IDEs as well. Okay, so let's get started. On the screen, I've got a basic test that I can use just to verify that things compile, link, and execute properly. So we can run it, and we see that our unit test compiles and executes successfully. This tells me that I've got Google tests set up in my project correctly, and I'm ready to start writing tests. I've got a Google Test Runner plugin installed in Eclipse, and that's what you see here at the bottom of the screen. The test runner shows all the tests that were executed and if they passed or failed, and this green bar on the right-hand side shows if all the tests passed or not. When it's green, then all the tests pass. If any of the tests fail, this bar will turn red. This is a typical layout for a test runner in an XUnit type testing framework. In this file on the right-hand side, I've got the list of test cases that I want to implement. These should be in order of increasing complexity from the simplest test case to the most complex. There are more complex test cases that can be added, but I think this is enough for this demonstration. Okay, so let's implement our first test case. Can I call FizzBuzz? To start, we enter the red phase, and in the red phase, I need to implement a failing unit test. So I'm going to repurpose this assert true test case to validate that I can call the FizzBuzz function. Okay, can call FizzBuzz. I'm going to remove the assert true and standard string result equals FizzBuzz. And when I try to execute that, there's errors. If we look at the errors, undeclared identifier FizzBuzz. Now I have a compile error because the FizzBuzz function does not exist, and per our 3 laws of TDD, not compiling is equivalent to failing. So we've successfully implemented a failing unit test, which means we've completed the red phase. So now we move on to the green phase. We need to make this test pass. We can do that pretty simply by implementing the FizzBuzz function. This shouldn't be the final implementation of the function. This should just be enough to make this test pass. So I'll do that now. Int value. And that passes. Excellent. We've made our unit test pass with the simplest change we could make to the production code. We're done with the green phase and it's time to go on to the refactor phase. Is there anything to refactor here? I don't think so. There's nothing here yet. So let's mark this as complete in our to-do list and then go ahead and move right back to the red phase and restart our TDD cycle with the next test case. So I'll go ahead and mark that one as complete. Okay. So on to the next test case. I need a string 1 returned when I pass in a value of 1. I'm in the red phase, so my first step is to implement a failing unit test for this functionality. Okay. Test FizzBuzz test returns 1 and passed in with 1 passed in. Okay. Standard string result equals FizzBuzz1 assert string equals 1 result.cstring. Okay. And that fails. We see it's for our new test case that it's failing. Good. Okay, so now that we've got our failing unit tests, we can go to the green phase and make this test pass. To make this test pass, we'll need to make the simplest change we can to the production code that will make it pass without breaking any of the other tests. That should be pretty easy in this case. We'll just modify the code to always return a string of 1. So instead of the empty string, I'll just always return 1. And then makes a test pass. And both my original test and the new test pass. There we go. All of our tests pass now. So on to the refactoring phase. Is there anything here to refactor? Is there any duplication? There is. This call to FizzBuzz is duplicated in both of my tests. That first test case is no longer really needed as the second test case validates that FizzBuzz can be called. I'm going to go ahead and remove that first test case. Okay, I don't think there's any more refactoring to be done. Let's mark this test case complete and then back to the red phase in the next test case. Mark it complete. Okay, third test case. In this test case, I'm going to need to return a string of 2 when a value of 2 is passed in. I'm in the red phase, so the first thing I'm going to do is implement a failing unit test. FizzBuzz test. It's actually tests. Returns 2 with 2 passed in. Okay. Result equals FizzBuzz 2 assert string equals 2 result.cstring. Google Test does its string comparison on C-style strings. So we cast the standard string to a C string here. Okay, so we've got our new unit test written, and it fails. Okay, now that we've got the failing unit test, I can go to the green phase and update the production code to make the test pass. I'll make this test pass by generalizing the production code. I'll make it more generalized by converting the passed-in value to a string. And this is a common practice with TDD. You'll implement some functionality in a very specific way in one test case just to make that test case pass. And then you'll generalize that production code in other test cases to make all the test cases pass. So instead of returning this very specific 1, I will convert this to a string. And now my tests pass. And now that the test is passing, we can go on to the refactoring phase. Now in the refactoring phase, we look for any duplication or other cleanup in the code. Is there any duplication here? The structure between our two tests is duplicated. Let's refactor that into a simple utility function that can be used by our tests. Okay, so I'm going to create a void check FizzBuzz function, which is passed in the integer value that we want to test with and the expected result string. And in this function, we will follow the same pattern. Expected result, C string, result.c string. change both of my test cases here to use that new check FizzBuzz utility function. And after all these changes, I rerun my test to see that they still pass. Okay, great. Let's mark off this test case and we'll move on to the next. Mark that complete. Okay. In this test case, things are going to start to get a little interesting. We're going to make the code return fizz when a value of 3 is passed in. Again, we're in the red phase, so our first step is to implement a failing unit test. We'll use our utility function to implement it. Test FizzBuzz tests returns fizz with 3 passed in. Check FizzBuzz 3 fizz. And the new test fails. Okay. Now that we have a failing unit test, we'll go ahead and move on to the green phase and make this test pass. We want to make the smallest and simplest change we can to the production code to make this test pass. That can be very specific for this test case, and then we'll generalize it as we need to in the future for future test cases. So for this test, I'm going to update the production code to check if 3 is passed in, and if so, return fizz. If value 3 equals value, return fizz. Great. Okay, our test is passing. Let's move on to the refactoring phase. Is there anything to refactor? I don't think so. Let's mark this test case complete and then back to the red phase to enter another iteration of the TDD cycle. So we mark this complete. Okay, this next test case is very similar to the last test case. Here we want to make FizzBuzz return buzz when the value 5 is passed in. So let's implement the failing unit test. Test FizzBuzz tests returns buzz with 5 passed in. Check FizzBuzz 5 buzz. And it fails. Okay, now we're in the green phase, and we'll make this test pass by adding another if condition to the production code. If 5 equals value, return buzz. Easy. Okay, so now we go to the refactoring phase. Is there anything to refactor? Doesn't really look like it at this point. Let's move on to the next test case. So we'll mark this off. Okay, now in this test case, we want to generalize the production code to not just return fizz for the value of 3, but for 3 or any multiple of 3. We're in the red phase, so let's write our failing unit test. FizzBuzz tests returns fizz with 6 passed in, 6 being a multiple of 3. Check FizzBuzz 3, 6 fizz. Okay, we have our failing unit test. so let's go to the green phase and make it pass. I'm going to modify the if statement for the 3 to have it use the modulus operator to see if the remainder of 3 is 0. Let's make that change. If 0 equals 3, note value modulus 3. And that makes our test pass. Okay, great. So let's refactor. I think this FizzBuzz function can use a little cleanup to make those if statements a little bit cleaner. I also don't like the multiple return statements. I think I'm going to leave those for now. So let's do the next test case. Mark that off. Okay, so this test case is basically a repeat again of the previous test case, but this time we want to return buzz for multiples of 5. Let's implement the failing unit test because we're in the red phase. Test FizzBuzz test returns buzz with 10 passed in. Check FizzBuzz 10 buzz. Okay, and now we'll make it pass like we did before using the modulus operator. If 0 equals value mod 5. Okay, this is getting to be routine. Alright, let's refactor. Is there anything to refactor here? Any duplication? The expression in the two if statements in FizzBuzz are pretty much identical. I'm going to go ahead and extract those into a isMultiple utility method to try and make the code a little bit cleaner. So I'll do that now. Bool isMultiple int value int base. Return 0 equals value mod base. And then I'll modify the if statements to use the new utility function. Hopefully make the code a little more readable. And validate that my unit tests still pass. Great. Okay, on to the last test case. In this final test case, we're going to return FizzBuzz if the passed in value is a multiple of 3 and 5. We're in the red phase again, so let's go ahead and implement the failing unit test. Returns FizzBuzz with 15 passed in. Check FizzBuzz 15 FizzBuzz. Okay. All right, we have our failing unit test. Now let's enter the green phase and make it pass. I'm going to make this pass pretty simply by adding another if statement to the FizzBuzz function, checking if the value is a multiple of 3 and 5. Okay. If isMultiple value 3 and isMultiple value 5, return FizzBuzz. And it passes. Excellent. Our code is now passing all the test cases. So on to the refactoring phase. Anything to refactor here? I think this looks pretty good at this point. No more refactoring is really necessary for this simple implementation. So that completes the FizzBuzz code kata. In the exercises for the course, I'll provide some additional things you can do to add to this code kata to make it more challenging. In the next lecture, I'm going to go over downloading and compiling Google Test and getting it set up in Eclipse with the Unit Test Runner plugin.